Everyone. Welcome to the 9th event of ShareIT community. My name is Mario Grimaldi. I'm a software developer from ThoughtWorks Italy. And along with my other colleagues, Ronnie Cesana and Matteo Di Tucci, we are going to be the host for today's event. While people are joining, we just want to do a usual, let's say, brief introduction of what is this community and why we are here. And then we'll leave space to today's speaker for a very, very interesting talk. So let me start by sharing some slides that will help me explain a little bit better what we're doing here. So let's start from who we are. So who is ThoughtWorks? ThoughtWorks is a global technology consultancy company. It has, of course, many offices around the world. We are from the Italy office, which is based in Milan and also pretty new. And we will also have some news related to it. But we are overall distributed remotely. Usually, for example, I'm working from my home city, which is in Reggio Emilia, in Emilia-Romagna. So, knowledge sharing in ThoughtWorks is a very core, let's say, and fundamental principle. We do it in many, many ways. So we do it by writing books. You might see some of them in the slides that we are sharing right now. We do it by sharing articles on blogs and websites. You might have read something from Martin Fowler, but there are also many other top workers around the world that are sharing knowledge through their websites. We do by speaking at conferences and also by creating the Technology Radar, which is a publication from ThoughtWorks, a frequent publication from ThoughtWorks. So we thought, okay, we also need a way to share it in the local community, and here it is, ShareIT. What is the mission of our community? The mission of our community is to empower individuals and organizations, but how we do that? The main objective is to contribute to the community by sharing with the world our own experiences from project and from internal learnings that we might have. And we do it by doing regular catch-ups like the one you are basically participating today. Usually we are sharing a lot of tech knowledge, but we are not constrained to that. We also like to share knowledge around practices, design, diversity and inclusion, and more. Moving forward, what I would like to quickly touch upon is a very simple code of conduct in order to have the best experience for everyone. So first of all, feel free and actually encouraged to share over the chat and over the Q&A feature of Zoom your questions and your past experience, always keeping in mind to be kind with each other and understanding that there might be different levels of experience, of course, between the attendees. So any question is a valid question. There is no, let's say, silly question on all of that. So please be very kind and supportful to everyone. No more talking from my side. I already spoke a lot. Let me introduce today's speaker, which is Amit Dube. And he is a lead infra consultant, and today we'll speak about Terraform automated testing for CI/CD. Over to you, Amit.
Thank you, Mario. So I'll start presenting and put it in the slide mode. Okay, so welcome everyone. Good afternoon. Today, as part of this talk, I'll be talking about a bit of automation around testing for Terraform. It's as Mario explained, it's one of the experience that I had working with one of the projects that we completed recently. And we thought that probably it's a good idea to share it with the wider community so that we can share our knowledge with the external world. So let's get started. A bit introduction about me. As Mario said, I have been working as a lead infrastructure consultant for ThoughtWorks Romania. In total, I've got around 13 years of IT experience, and I was fortunate to work in different countries like India, Germany, and Romania. I'm a certified Terraform associate, and I have been writing testable and secure infrastructure for more than 3 years now. I have been using Google Cloud quite actively, and it's been 3 years I have been working on GCP, Google Cloud Platform. I'm also, other than on on LinkedIn. I'm quite active on Medium. I prefer to write some technical articles in there. So that's where you can reach out to me if you want to talk about something, or probably like to read some of the articles which I already published. Moving further, before we start, I thought probably I should present a bit of flow, how we're gonna start and how we're gonna proceed with one item to another. So although the focus of this presentation is only to talk about focusing mainly on the Terraform automation testing, I'll be starting with infrastructure as code. Then up to this point, I'll be taking a bit pause, and that's where probably we can also take some of the questions if there'll be something there. Then we'll quickly talk about Terraform in general, the tool for which we're going to talk about from the testing point of view. So I thought that probably it's a good idea to quickly talk about this tool first. And then we will jump to our main topic, and that's the automation testing around Terraform. And then we'll see some CI/CD pipelines where this automation testing setup is there, and it's kind of working already, and we're going to look into that. On the first point, I'll try to be a bit quick because that's not our main focus of this presentation. And so that we'll get more time to really talk about the main point of this presentation, and that's around Terraform automation testing. Okay, so let's move on. Before I move further, did any one of you ever thought about the time a team of engineers spent to test their code manually? I mean, it's not a question which I'm expecting an answer. It's just that if you can think of a figure in your mind before I move to the next screen. Okay, so moving further, it's approximately 1 million minutes per year. And this is an estimate for a team of decent size in any organization who has no automated testing setup in place. Okay, let's talk about infrastructure as code. Before we talk about anything new, we first of all look into the problem. And let's see what problems we had and why we actually even talk about infrastructure as code at the first point. So if a few years back, if you needed things to provision, probably some infrastructure or something, these were different roles that were played in this whole process. So you had a requirement that was coming from business, was analyzed by the business analyst, converted to some kind of technical form, discussed at the functional level, and then send it to the infra admins, basically, to take care of the infrastructure part. Probably the application part will be taken care of by someone else. But for the infrastructure side, it will be taken by infra admins. The infra admins were supposed to coordinate to different people. It could be somebody on the data center side. If there isn't enough capacity available in data center, then the colleague from data center might contact to the vendor to order some additional hardware or things like that. Then once the hardware is available, then somebody on the network side was supposed to set up the network so things are connected, basically. Then we had a role called configuration admins, where they were supposed to configure the server, because when you have a new setup, everything is blank, and we need some sort of softwares and configuration in there so that we can start working on that. Obviously, most organizations are concerned about security, and they have security admins. So they want some security setup to be done on the server so that some organization policies has to be fulfilled before the product team can start using things. And then we have policy admins. In some cases, they could be part of the security team itself, these two roles. But in some organizations, these are two different roles. So you already see the whole cycle, what it took actually to from the business requirement to come in till the point we actually have the hardware which we could use. And the same thing which I presented on the last slide, I just tried to describe it here on those specific points. So the first problem, which you could see already from the diagram, that the cost, hiring infra admins, network admins, and security admins has been really costly thing. The second thing is the time. We have so many steps to cover, starting from first to end, and it's obvious that it's really going to take a lot of time before we actually had the hardware we needed. In some cases, it could even take weeks to even months, probably few months, not even a single month. The third problem we had basically is that there are problems at different levels. So we already see a lot of people involved, and everybody has different ways of working. And if somebody didn't do things in an ideal way means the correct way, then there could be problems. And you might not even notice that problem unless the hardware that you get is not actually working in the right way. And then you start debugging and try to find out where this problem was introduced. And then you probably end up spending a lot more time just to debug the problem. So the time spent in provisioning the hardware was one thing, but then to fix the issues at different level was another problem. The infrastructure consistency, that was one of the major challenge. If I ask you even at this moment, if we have a console, let's say, and if I ask you to provision 2 machines, probably after a separation of few days, let's say, there are very good chances that these 2 machines won't be identical. We'll end up clicking either something additional, or we will just forget clicking something which actually needed. And that end up having infrastructure, missing infrastructure. So probably a few months back, we created a VM instance with some different configuration. We needed something, but then after a few months, we end up creating something different. Obviously, there were things like creating documentation, taking screenshots, everything was tried, but obviously those were not ideals. We are humans, we tend to forget things, and that's kind of normal. Another problem was the configuration drift. It's more like having a different configuration in different environments. So let's say we have environment like development, staging, and production. And generally, we want these 3 environments or all these environments to be quite in sync, so that the kind of testing we do in one environment is still valid for the second environment, so that we expect our application to behave in the same manner across all environments. But if you do everything manually, there always been chances that you had different set of configuration in development, different set of configuration in staging, and then different set of configuration in production. And that end up having different application behavior across environments, something that we never desired. And last but not the least, the documentation. As I said, we had some creative ways of doing documentation, taking screenshot, creating a lot of confluence, writing steps like step 1, click here, step 2, click there, take the screenshot, but nothing was ideal because it's always faulty. If you miss something, probably the vendor or the software that we're doing made some upgrade, and now some of the things moved here or there, and now the screen doesn't look exactly similar to when the screenshot was taken. And that's, again, the confusion start, and then you have to update your whole documentation. So these were some of the pain points that we had when we were trying to provision infrastructure manually. And that's where, so now we understand the problem, and that's where we come up with a solution called infrastructure as code. These are some of the definitions that I found, but in general, the infrastructure as code is like managing and provisioning infrastructure through code. So in short, we're going to write code, parse or push it against a tool which can understand this code, and then provision the infrastructure for us. What it helps us with, and we're going to probably talk about it a bit even more in detail, but what it really helps us with to have consistency, repeatable routine for provisioning and changing system and their configuration. And that's kind of give us some consistency on the infrastructure that we are trying to provision. But we're going to talk about some of the advantages in the further slides. So bit of architecture diagram on how infrastructure as code work. we saw the definition in the last slide, but I thought I should put it in some of the nice icons here. So be as a developer is gonna write code. If you are application developers, then probably already know you probably write a lot of application code already. But what we're gonna write here is basically an code which describe our infrastructure. In some cases, we also call it as configuration, but we generally call it, I mean, I personally I personally think of calling it a code actually. Then we have a tool, and what this tool does, it tries to parse our code. And as part of parsing, we also do different things actually. Those are kind of important. And one of them, obviously, the testing of our code and the policy validation. We're going to talk about them actually later in the slide, because that's the main theme of our presentation. And once everything looks okay, this code gets applied to the specific system. It could be the public cloud provider like Google, GCP, AWS, or Azure, or it could be any other system. It could be even some on-premise server where you want to deploy your infrastructure. In terms of infrastructure as code, we have two approaches and kind of tools that currently are available in the market to do infrastructure provisioning for us. And these approaches is called declarative and imperative approach. In declarative approach, we just tell the tool what we want and what is our desired state actually. We doesn't tell it how to do it, and then in general, tool knows how to reach to the desired state. That's called declarative. And we're gonna look into them with some illustrations basically in the future slides. The imperative is different. We have to tell the tool what to do, and we also have to tell the tool how to do it, what command to run, in what order to run them in order to provision the infrastructure. Let's talk about declarative approach a bit more in detail with one illustration. So let's say if you go to one of your favorite burger shop and you're looking for a vegetarian burger, and you just tell them that you need a veg burger, and in most cases, they will get, okay, here you are, thank you, your burger is ready. That's good, because they really know what vegetarian burger means. And that's exactly what declarative means. So in the declarative approach, you just tell the system what you need, and the system is going to give it to you. It will try to reach to the desired state, your desired state. In some cases, you probably need some change in configuration. I mean, obviously not everyone has the same taste. Probably you need different salt configuration. That's okay. Probably you also want more spices, some different spices, not the actual default configuration. And that's also possible with declarative system. So declarative system comes with a default configuration. They know how to do it, but they also gives you the possibility to override some of the default behavior, like the salt, in this case, the spices. Another thing which is really important with declarative system, that the order doesn't matter. If you think about spices first and the salt later, that's absolutely fine, because then it's gonna mix up the spices and the salt, because for it doesn't matter. It actually know in what order it has to mix things. It's just taking your input in a specific order, but it's still gonna process everything in the right order, which it actually knows. Probably when the burger is almost ready, you think of something else, and now you say, okay, the burger is ready, but I needed less tomato and more cucumber. That's all right, because the declarative tool maintains a state. So it actually knows the current state of your burger. And if you tell it to modify your burger, probably add less tomato and more cucumber, that's possible, because it knows that there is a burger with 5 grams of salt, 5 grams of spices, and then it's gonna adjust other things and give it the final burger to you. And that's the beauty of declarative approach, basically. So it's give you all set of flexibility. Moving further to so just a conclusion, basically. So in case of declarative tool, the order is not important. You can give instructions in any order. And the interesting thing is that the state is maintained. So it at every point in time, it knows where we are, and then it can derive what it needs to do in order to reach to the desired state. In the imperative approach, it's a similar example. We need a vegetarian burger, but the burger is not yet ready, because if you need a vegetarian burger, you actually have to tell the tool what you need to do in order to make a vegetarian burger. So you have to tell the exact instructions. So you will tell, okay, take a burger, add some sauces and cheese probably, add some salata, it's salad, and some potato patty. And you said, okay, now, okay, the burger is ready, pretty good, that's fine. So you tell it the exact set of instructions, and the burger is now ready. But what about this? When the burger was ready, you just realize, okay, I forgot to talk about tomato, cucumber, and corn. I really needed them. And that's where the challenge starts, because the imperative tools doesn't maintain state. They really do not know that there is already a burger with some sauces and cheese, salad, and patty. And you just want to add something additional on top of that. They really have no way to find it. And when you're going to add this additional thing in there, it's going to prepare a new burger for you with everything which you've done in the past. On top of that, tomato, cucumber, and corn. And that's the imperative approach, basically. So the order is very important. I cannot tell the tool to mix the sauces first and then take the burger. That's not how it's going to work. So the order is important. You have to give the instructions in the right order. And the state is not maintained. So at any point in time, if you miss something, then it's going to be a fresh start for you. Okay, so we talked about infrastructure as code. We looked into some problems that we had before infrastructure as code, and we also talked about some of the approaches that we have to approach infrastructure as code, like declarative and imperative. So what's the benefit? The benefits are pretty similar, and they come from the problems that we had. So we have cost reduction. You don't have to hire high, probably experienced resources on the network, or probably on the data center side, or probably secure. You still need people, but the kind of role they're going to play is not going to be that complex. And that's why it probably doesn't require that much of cost to maintain all this. The increase of the deployment is higher. Now the developers had more control. They're going to write code and then provision infrastructure. The less errors, because less people are involved. So we have less hands, obviously, the less likely to make errors. The consistency is higher because we are writing code and then just applying it. And when it's pushed to version control system, we know that it's the same code that's going to be applied in the next environment. And also even after 3 months, the same code will be applied. The configuration drift. So if we wrote the code, pushed it to version control system, and if we apply the same code to development, then we are sure that if we don't push anything new, the same code will be applied to staging and production. And that will basically eliminate that configuration drift. The documentation comes with the code nowadays. So when we write code, obviously we are documenting our infrastructure. And one of the beauty of infrastructure as code is that with infrastructure as code, we can actually see how our infrastructure evolve over time. So we can go to different commits and look into what was the requirement, why something was changed, who changed it, different commit messages, and all those things. And other things which are comes, and that's where we're going to focus more in next few slides, is automated testing and automated deployment. And that comes because now if we can write infrastructure as code, all the coding strategy like automations around testing and automation around deployment can be achieved with infrastructure as well. Okay, so that's the benefit. On this slide, these are some of the infrastructure as code tools that's probably some of you are already working with. One of the first tool that we have, and we're going to talk about this tool even a bit more in detail in next few slides, it's called Terraform. It's a tool which is developed by HashiCorp, and it's one of the leading industry infrastructure as code tool. What makes it different that it can actually provision infrastructure with multiple systems, basically. So it can provision infrastructure against Google Cloud, AWS, Azure, or even things like Kubernetes or something else that you heard. So that comes with Terraform. But other than Terraform, obviously, we have other individual or the cloud-specific infrastructure as code tool like Deployment Manager, that's for GCP, Cloud Formation for AWS, and Resource Manager with Azure. But the other tools that are getting popular, and I'm sure that as the time will progress, there'll be more and more infrastructure as code tools in the market. Okay, so as I said, I'm gonna pause here a bit before talking about Terraform, and probably Ronnie, are there any questions that probably we should be taking at this time?
So far, I don't see any. If you have any questions, feel free to use the Q&A feature on the bottom. It's easy. If there's anything you don't understand or anything you'd like to have repeated, just let us know. For the time being, there's no questions. Actually, I have one, if I may. So you talked about cost reduction, and when you were explaining the way things happened before infrastructure as code, you also mentioned that you would have to hire different people, including infra admin, network admin, and security admin. Are we implying that all of this knowledge goes into the infrastructure? Or maybe you're coming to that next. I don't want to run ahead, but are we collecting all of this knowledge in one role?
Kind of not really, because the thing is that in many cases, if we are moving to infrastructure as code, and I mean, the statement that I made, I kind of assumed probably, so I think I need to correct myself. Probably, yes, depends on how you see infrastructure. If you still believe in maintaining your own data centers, then some of those roles might still be relevant. But yes, some of the knowledge will shift to the infrastructure side. So the infrastructure developers are going to have some of that knowledge. But there will still be few roles that will still be relevant. So the cost factor might not be that significant in my view. But if you decide to go with public cloud, like services like platform as service or software as service, then yes, those roles are eliminated because now they are on the cloud provider side. And you just need to understand how to write infrastructure. You really don't have to worry about managing your infrastructure. And that really end up reducing the cost to a higher extent. And the reason I put it in the infrastructure as code, because now with infrastructure as code, you really have the possibility to actively engage with public providers. We have more and more public providers coming with integration with infrastructure as code tools. And that really gives us the possibility to start using all these models coming from public cloud. And that really end up a cost reduction in many cases. So,
yeah.
Okay, thank you.
Thank you. Okay, a reminder, if anybody has any questions, feel free. I think we can continue and then we will pick up any questions as we go. Thank you.
Perfect. Thanks, Ronnie. Okay, let's talk about Terraform, the tool, infrastructure as code tool that we, in the last slide that we saw that it's one of the leading infrastructure as code tool in the market. So what makes Terraform different from other tools? What we see here, it's most of these things applies to any infrastructure code tool that you see. But one of the really interesting thing about Terraform is that it's cloud agnostic, which means it can provision infrastructure for different cloud providers. And that really makes it appealing. And that's why it's also one of the leading tools. Another thing, which really worked pretty well with Terraform, that it has a very simple workflow. And the workflow remains consistent no matter which cloud provider you use. So you're going to use the same workflow, init, plan, and apply. And it's going to provision the infrastructure for you, irrespective of the cloud provider. And since we talked about declarative and maintaining state, Terraform is a declarative tool. So you just have to tell Terraform what you want. You don't have to tell it how to do it. And it also maintains states, which means if you provision some infrastructure and tomorrow if you need to change something, that can be very easily done because it understands what you currently have by maintaining the state. And when you make a change, it tries to find the delta, so only the change part, and then try to apply that change to the target cloud provider, whatever you have, GCP, AWS, Azure, or anything else. And that's how the Terraform works, basically. We're going to talk about a bit of a Terraform structure here. So in general, Terraform resources looks like this. If you're already doing Terraform, then I'm sure that you're familiar. And this is how we write Terraform resources, like the name of the resource, which also contains the provider that this resource is linked to. So if I'm writing AWS, which simply means that this is an AWS resource, and then inside the block, we write some kind of configuration. Obviously, in many cases, there are some default values and you don't have to override things, but you have the possibility to override the default configuration, as we saw in the previous slide with declarative tools. The important thing is that it works with providers, and that gives it a flexibility to provision infrastructure with different cloud providers. So with GCP provider, we can provision infrastructure with GCP. With AWS provider, we can provision infrastructure with AWS. It maintains state, we talked about it, and it considered that state as the source of truth of the current infrastructure. So Terraform has a simple workflow, we talked about it, and it has things like init, plan, and apply. And during the init phase, Terraform basically downloads all the providers that it needs. During the plan phase, it actually look into the your current state and the change in the configuration file that you did, and then it suggests what change it's gonna do in order to reach to the desired state. So comparing your current configuration with the current Terraform state, and try to find the delta, and then present it to you so that you understand what Terraform is gonna do, so that you can verify things and see if everything is okay. And during the apply phase, the change which was suggested and not applied in the planning phase, it actually got applied to the target environment or to the target cloud provider, depending on what cloud provider we have. So that's how the whole Terraform function works. We write the code, we give it to Terraform, we initialize it, we plan it, and then we apply it. And that's the whole life cycle, kind of whole cycle of Terraform. Okay, so we'll go to automated testing, and that's where I think we're gonna focus and see how to achieve automated testing. But before we do it, obviously the first question we ask as an engineer, why would we do something? So obviously I put in some motivation in the beginning, and one of the motivation is that if you have a team of decent size, you're already wasting around a million minutes per year to testing your infrastructure manually, even for a decent size of team. And probably you like to save this time. Probably you like to spend this time to something that you probably enjoy or like. And that's where automated testing can help. The second really important thing about automated testing is that it can help you to automate your full CI/CD process, in the sense that you can build things, you can build something, but before you deploy it, you want to test it. And if you don't automate this part of this entire flow, then the full CI/CD cycle cannot be automated. So the automated testing is a very essential ingredient for continuous integration and continuous delivery. And this is another reason why we need automated testing. So we talked about automated testing, and probably at this point, I managed to convince you that automated testing is required. But then comes another question, how do we do it? In Terraform, the automated testing has 3 stages. The first stage is called static analysis. And as the name says, it's like analyzing your code without executing it. So you write the code, and then we use certain tools obviously in an automated way to analyze that code. And obviously we're going to talk about it a bit in detail, and also the kind of tools that we can use. But that's basically what static analysis is. The second stage in this process is called incremental analysis. In incremental analysis, we only analyze the delta. We already understand from the previous slide that Terraform creates delta in the sense that when we provision our infrastructure and later on when we want to change it or add something, Terraform derives what it has to do in order to reach to the desired state, which means it has the delta, the changes that it has to apply. And we're gonna analyze those changes before we apply them. And that's called incremental analysis. And last but not the least is called functional testing. It's pretty much what we do when we write our applications. We're gonna write the test cases. We're gonna provision our infrastructure to a temporary environment. We're gonna run the test cases against that environment and see whether everything is okay, whether all the test cases are green. And when everything is green, then only we will apply the changes to the actual environment where the infrastructure has to be provisioned. And that way, we actually check the functionality of our infrastructure, the way it was supposed to behave. Okay, so let's talk about each of these stages and see what tools we can use and how they can help us. Starting with static code analysis. So as we said earlier, it's like analyzing the code without executing it. And the first tool that we have in the list that helps us with static code analysis is called TFSAC. As probably the name says, it's a tool which helps us with some of the security best practices. And the way it does, it has some built-in rules. And when we apply it against our code, it actually tries to validate our code against those set of rules. Some of the examples where it can actually help, like let's say you provision a database, but you didn't provision the backup, which probably is essential, but you didn't notice. Probably you are new to the cloud and you didn't realize that probably a backup solution is also needed. If you supply that code to the TFSAC, it's going to mark that code as failed, because if you have a database, then it actually proposes that you have to have a backup database as well, a backup instance. Similarly for keys, if you create some key and they don't have an expiry, like infinite time or something, then it's going to complain about that. Obviously, you can decide what rules you want to escape and kind of ask for an exception. But in general, this is what it does, basically. It's going to apply some best security practices for your code. And it actually does really wonderful job, because it actually helps you to take some conscious decision on security, something that probably you didn't notice, but now the tool realize that you have those gaps. You still might decide to add an exception for that, but now you have them in your mind, basically, and later on you might come back and try to fix them, even if you probably go for an exception at this moment. So it really helps you to take some conscious decision on security. The TF-lint, if you're doing some front-end development or things like that, then you probably know what linters are. They help us checking quality and formatting with some built-in rules again. And this is exactly what TF-lint does for us. It's a linter for Terraform. And it enforces some best practices, like not using some depreciated syntax, things like that. It also helps us to follow a common coding convention within the team. So if you have a team of developers with multiple people, you really want to have some set of standards in terms of how to define your variables, how to create some naming conventions for the files and things like that. And this is where TF-lint can help you actually. So it helps you to adopt a certain set of best practices in terms of naming conventions and formatting and things like that. And another thing that comes with Terraform itself, with Terraform CLI, is called Terraform Validate. And the Terraform Validate is something which helps you to syntactically and semantically validate your code. And all these can be done as part of while you are writing your code. You really don't have to execute your code or apply your code to a specific environment. You write your code and you can run this tool even in your local environment. And that's why these are the first step before you actually go to any further analysis. This is the first thing that you should be doing. So I think we talked about them, but this is a quick summary. I thought to put it in the slide so that you basically understand bit in detail what TFSec does. But this is exactly what it does. It understands major cloud providers, and even in some cases, some minor ones, have some built-in rules, evaluate them, and try to find out what should be the best security practice for that particular infrastructure that you have written, and then gonna recommend you, and not only recommend you, it's gonna break your build. If you're doing it as part of CI/CD, then it's gonna stop your build and ask you to fix it until unless you decide to add an exception. And this is how what TF-lint does. It's like, I mean, this is how the TF-lint configuration file looks like. So these are kind of rules. As I said, it works with predefined rules. You can decide to enable some of them or disable some of them. If you decide to disable them, obviously that rule is not going to function. But at least now you are conscious that you disable something, and probably you come back and decide to enable it later on. So that's how Terraform lint actually helps us with some code formatting on things like that. And then another tool is Terraform Validate. As I said, I tried to put in some examples so that you probably figure out how it works. So if you have some good configuration, then Terraform Validate is going to give you a message like that the configuration is valid syntactically and semantically. But if there are problems, then it's going to complain about them. Things like that. Probably you did some typo. You wanted to reference different variables, but you created different variables, but you're referring a different variable here while writing the code. So things like that. These are the things that can be validated while writing your code, and also we're going to see them in the pipeline. So that's about static code analysis. The second stage that we saw, it's the next stage, because that's something requires a bit of setup, and that lets you to analyze the data by executing your code, not applying, but only planning. So what it does, as I said, Terraform as part of planning tells you what it's gonna do in order to reach to the desired state, which means it understands the data. And through this command, Terraform plan, we can try to find the delta, and then we convert that delta to a JSON format, and then supply it to a tool called Terraform Validator. It's a tool which is designed by Google, and what it actually does, it helps us to validate our infrastructure against some organization policies. So here you see here in the path, we have the path to the policy library. And that's really important, because if you have an organization, you can have some sort of policies which you want to be enforced, probably like a policy admin for your organization. And then you want to ensure that anybody who is provisioning the infrastructure should stick to those policies. These policies should never be violated. And that's what Terraform Validator helps us with. So every time you applying the changes, it is trying to find out what change you're going to make to your infrastructure, validating that change against the policy library that you have. And if anything is violated, it's going to complain about that, and it won't let you proceed further and provision your infrastructure. And that really helps us to maintain a uniform policy for the entire organization. Another thing that we have is called functional testing. If you're a developer and writing your infrastructure already, then probably some of you follow this simple workflow where you write some code, you push it to a different branch while making some changes. And then in many cases, we ask for some approvals so that somebody else can also review your code and then tell us whether everything is okay. Although this person who is going to review this is going to try his best to make sure that you really provision, I mean, the code is still okay. And probably it's actually going to do what it is supposed to do. You can never be sure unless this code is actually merged to the main branch and applied to the actual environment. And if it actually doesn't do what it was supposed to do, then you have a problem, because you have to kind of either roll back or apply a fix depending on the use case that you have in hand. But obviously it's not the ideal scenario. The ideal scenario would be that if while raising a PR, you kind of, instead of a manual review, you kind of can have an automated process where the code that is coming here can be tested against the test cases, the proper test cases that you write. Let's say if you want to create some storage bucket, then you have a test case which actually checks whether the storage bucket actually created or not, with some attributes, things like that. And if you have the possibility to do that kind of testing functionally on your code, then you are really sure that the code you are writing is actually doing what it's supposed to do. And then you can happily merge it in an automated manner and then trigger the build automatically. And that's going to complete your full automation. And that's exactly functional testing is all about. The functional testing we do with a tool called Kitchen, with some integration with another tool called Inspect. In general, the setup of Kitchen looks like this. We have some code here. It's a Terraform code that we want to provision. We call this code under a fixer directory right here by writing some Terraform files, but actually we are calling this code from here. And then here in the integration folder, we are writing some test cases. Excuse me. The test cases are written in Ruby, and the configuration of this tool is actually done in this file called kitchen.yaml. What this tool does basically, it actually provisions your infrastructure against an environment that you configure this tool. So it provisions your infrastructure, then it actually execute the test cases which are written here under this file and run those test cases against the infrastructure that you provisioned. If everything is okay, then it's gonna delete your infrastructure completely because it's a temporary setup, it's a sandbox environment. And then it's gonna move on and continue your pipeline to the next actual environment and deploy your infrastructure. If any of the test cases fails, then the pipeline is gonna stop right there because your code is functionally not correct. Probably it's correct syntactically, probably it has the right coding conventions and things like that. And probably those validations are fine, like static code analysis. It also has the policy compliance, so no policy is getting violated. So the incremental analysis is also okay, but your test is functionally not valid. And then you're gonna block at this stage, and then you decide to fix it and then move on with your pipeline. What Kitchen also helps us, if you're already doing some test-driven development in your day-to-day life, then Kitchen can actually help you to write test-driven development with Terraform. You write your test case, a failed case, as a business requirement, then you run the code. It's gonna fail because you don't have an implementation for that. Then you start writing the code until you get the test case green. And that's also one of the major advantage of doing functional testing with Kitchen. So what's the Kitchen workflow basically? It's kind of similar to Terraform. It goes in this sequence. So we run commands like kitchen create, and that's where Kitchen actually initiate the workspace and everything that you need to run Terraform code. Under the hood, Kitchen actually calls Terraform CLI and actually runs Terraform CLI to do everything for you. In the Kitchen converge state, Kitchen does Terraform apply basically. So everything that you written and want to provision will be provisioned as part of this stage called Kitchen converge. The Terraform verify stage is where the test cases are triggered. So the Ruby file that we had written will actually run against the infrastructure, and it will actually validate your infrastructure. And the last step is the kitchen destroy. And this is something that you will run anyways, irrespective of whether any of these steps fails, because once infrastructure is deployed, you probably want to destroy it. And next time when you fix the problem, probably with verify step, it's going to provision the infrastructure and verify things again. Okay, we talked about the things probably in bit of sequential manner, but how does it looks like in the pipeline? So if you see this pipeline here, we are doing things like TFSec and TFLint, and mostly we do them in development environment because that's where you want to validate your infrastructure against security best practices and also for coding conventions. Yeah, here everything is green, but anything which fails, this pipeline is not gonna proceed. It's a GitHub pipeline, but the same concept can work with any CI/CD tool. The Terraform Validator, generally, at least this is what our setup is, but it again depends on organization. We do it for all three environments because in many cases, you tend to have different set of policies for different environment. You might end up having some different policies for development environment because you want to offer some flexibility to your developers, but probably you want to be a bit more strict in staging and production, quite normal. And that's why the Terraform Validator steps against validation for policies can actually run in many environments. And that's how the pipeline with the static code analysis and incremental analysis should look like. For kitchen testing, the pipeline looks like this. So you actually do the initialization of kitchen, then we provision our infrastructure with kitchen converge. We do verification, and that's where I wanted to show you how the test cases runs. Kitchen can actually run your G-Cloud commands if you're obviously working with Google Cloud, but obviously with other cloud providers. And it also has some predefined resources, those can be used, but it can actually test the infrastructure in the sense that it can check whether an actual service exists, whether you get the right code, you even hit an endpoint and see whether it was actually reachable or not, things like that. You're going to write both kind of tests. You're going to write a failed test, you're going to write a successful test, and if everything is okay, then the kitchen workflow will turn green. But if something fails, then yeah, things gonna stop there. So that's how the kitchen setup actually looks like in the pipeline. And that's pretty much it actually. This is the URL, because I talked about quite a lot of things, but I thought probably it's really important that I point you to some of the documentation on some of the tools which I talked about. So if you go to this URL on github.com, Amit Dube ShareIT, then I put in some relevant URLs on some of the tools. So feel free to go in there, and if you're interested, and obviously if it's relevant for the use case or the kind of infrastructure work that you're doing, then feel free to look into that documentation. I also wrote some article for test-driven development with Terraform on Medium, and I also put the URL in there, so feel free to check that. And yeah, feel free to connect on LinkedIn with the URLs that with the link that I mentioned earlier. And with this, I'll probably hand over to you, Ronnie, for questions.
We have some questions. So there was, I think, more of an observation when you mentioned the fact that Terraform is commonly used because it's a cloud agnostic. And somebody's asking, I can't see the name, I'm sorry. Somebody is saying, I would argue that Terraform is a multi-cloud solution, but not cloud agnostic. What is your comment on this? I can't see who asked this question. I'm really sorry. It seems like it's coming in from a bot, but I'm not sure. So what would you say?
I mean, what would have been really nice to if the colleague or somebody who asked this question probably could have explained it, how he sees the difference between its cloud agnostic nature and how does he feel actually, because what I feel is that Terraform helps you to provision infrastructure with the same set of workflow irrespective of what cloud provider you choose. And that basically makes it cloud agnostic in my view. But it could be that, yeah, there might be some different understanding on how the cloud agnostic nature is actually defined. And that's where it would have been really nice to hear
There's a
from
clarification. There's actually a clarification. So they will say you will have to rewrite the Terraform code for every cloud. And maybe what they mean is that you cannot have recipes or declarations of state in Terraform, which would apply to different cloud vendors. What you are saying is maybe the Terraform tool as such can support different clouds. However, your code won't be reusable. That is my understanding. I hope I am getting this right. Yeah. So there's a confirmation. So would you agree that in terms of provisioning the same infrastructure or a similar functional infrastructure on different clouds, you would have to write a different code? Would you agree to this statement?
Yeah, fully agree, actually. Yeah, that's a really good observation. So thanks for that. Yeah, that's pretty much right. So yeah, we have to rewrite the code. The only thing which Terraform probably helps us is to reduce the learning curve, basically. So even if you're gonna write a different source for AWS, you will still follow the same workflow, and probably there's almost very little learning curve, because yeah, you're just going to change the resource and things gonna work. So yeah, fully agree. Thanks for that.
Consistent approach. Thank you, whoever wrote this comment. That was really helpful. And then we have another question. This is coming from Alena. Hope I'm pronouncing it right. What do you think about TerraTest instead of Kitchen Terraform?
Yes. Thanks for that. TerraTest is another tool basically which can kind of do testing with Terraform. It's based on Go, if I understood correctly. One of the things, so I used TerraTest in one of my assignment, and one of the things which I really found difficult with TerraTest was the usage of Go. So you really have to understand how Go works and how testing works in Go before you can start using TerraTest. And second thing, it in my view, or probably it could be that I didn't explore it too much, but when I compare it in terms of features that Kitchen offers in comparison with TerraTest, I found that TerraTest doesn't supporting that much testing level. So with Kitchen, we can go to a very deep level of attribute to any service. We can see whether a specific service with a specific configuration, with certain attributes, with certain value, is actually configured, and compare them and then check them. And when I use TerraTest, I felt that this was impossible. It could be I'm wrong. And that's one of the reasons why I personally recommended to go with Kitchen in my project. But it would have been really nice to listen from you. But yeah, I fully understand, and I fully agree. It might depend on your use case, but I personally recommend Kitchen because yeah, I enjoyed working with it, and I found it more functionality rich as compared to TerraTest. Okay,
so Alena, if you think your experience is different, maybe those things that Amit couldn't find in there, it might be actually very good to connect and share your experience. So Amit shared his LinkedIn also profile with us, so it might be interesting if your experience is different. Do we have any more questions? Anybody feel free. There are no stupid questions. Usually I ask them. So there's another question from Raja or Raya. I'm sorry. Would Pulumi be a better choice than Terraform, as it allows any language to be used for infrastructure as code? What is your experience there?
So I'm reading. So thanks for that. And yeah, it's kind of a very debatable question actually, because so unfortunately I never used Pulumi on a production environment, but I kind of play around with it and try to read, because it's normal. If you're using Terraform, you try to read about other tools, at least the popular ones in the market. It could be that it might become popular and people start using it. There's one good thing about Pulumi, that it probably has a less learning curve, because depending on the language that you're already familiar with, you start writing your infrastructure. But what I felt with Terraform, in the beginning, it probably seems a bit discouraging that you have to learn a new language, HashiCorp configuration language, HCL. But this language is really, I was really quick to get the language, and it really offers a lot of functionality, which you might not have in other. So what Terraform is actually doing, it actually offering you a language which ends up giving you a lot more functionality on what you can do on your infrastructure. While Pulumi gives you flexibility to experiment with different language, it might not be able to support the different in-depth feature of each language from that infrastructure point of view. So while you have the flexibility, you might end up having less features. And that's the kind of trade-off I could see actually between Pulumi and Terraform. So, but yeah, go for it. Obviously there are a lot of options, and I love looking into multiple options. Although I'm pretty good with Terraform, yeah, I would still like to play around with Pulumi, but that's my view actually, looking into what I see currently in Pulumi and Terraform.
Very good. Thank you, Raja, I'm sorry, for the question. Good point. I would actually have another question, if I may, and then I'll shut up, I promise. So you mentioned among the different things that infrastructure as code can provide for you, documentation, which is always up to date. It cannot be deprecated, because it cannot be obsolete, because it's, of course, is actually what you are applying. I wonder, with comparison with what TDD and what unit testing can do for you, also providing documentation on what you are testing, would you say that to some extent this is also valuable when you do testing on the infrastructure? Do your tests say much about what infrastructure you expect to be able to do, or what services it can be providing?
Very interesting questions, and thanks for that, Ronnie. So one of the really good advantage, and probably I'll probably refer to the last part of the presentation, that where we actually were talking about functional testing. One of the really good feedback I would say I have when we start doing functional testing in our project, that we were not only, so with infrastructure as code, you're documenting your infrastructure. There are some repetitive code in Terraform, and you write modules for them so that you can reuse them. But in many cases, when you write modules, you have to tell people how to use them. It's like giving them a working example of your module. And what testing is really helping us, because for every module that we are writing some functional test cases, which means how to use that module with different parameters. And then what's going to be the end result of that module with those different parameters. And what it really helps, and as you correctly pointed out, this is actually resulting in another set of documentation, which actually automatically document the different usage of that module. And what the feedback that we have from different teams, they really find it convenient, because then they go to our test cases and quickly find the set of code that we have written there and see, okay, this is how they can use this module. This is how they can use this piece of code. And they also know the behavior, because that's how the test cases are written. So yes, it's really an addition on top of that, and that's really helpful. So thanks for that. Thanks for pointing that out.
Thank you very much. So as I see, we don't have any more questions, so I will leave it to Mario to complete and close up. Thank you very much, Amit. I'll leave it to Mario.
Thanks, Ronnie. Thanks, Amit. I think I'll share again the slides to help me close up and wrap up the event. So, okay, thanks again, Amit, for the very interesting talk, and also for all the questions and additional information we discovered about Terraform automated testing. very quickly about the next event that will be around mid-July. We have a special news, actually. It will be about Usability Testing 101. Our colleague Raffaella Roviglioni will be the speaker of this talk, and it will be the very first in-person event of the ShareIT community. It will be held in our Milan office. Places for now are not limited, but we don't have, let's say, an enormous space. So if you want to join, please reserve your seat by going to our meetup page where we have the event and joining with the attend button. It will be a very, interesting and different event. We're also planning to have some networking time after the talk in order to, meet each other in person and have some very interesting conversations. So please, join us. It will be around 13th of July. As always, at the end of this talk, we are going to share with you the recording of this event, the slides that Amit shared with us, and we are going also to share with you a link to a Google form in order to collect feedback from you about the organization of the event, the content of the event, and how it went overall. If you have any suggestion or tip to improve your overall experience, please feel free to use the Google form we are going to send you in order to provide us this feedback so that we can improve every time. I guess that's it. So we reached also the conclusion of this event. Thank you everyone for joining. Thanks Amit again for the very interesting talk, and we'll see you at the next ShareIT event. Thank you very much.